The last concept that we are going to study as we're looking at parabolas is taking an equation and modeling it in the standard form of the conic section of parabola. And this is going to involve one of your guys' favorite concepts that we've learned this year, and that is completing the square. So keeping that in mind will hopefully help you as we walk through this process. So the goal in these two examples is to get this equation that I've given you into the standard form for a conic section parabola, and once you are in that form, to be able to identify the vertex of the parabola, the focus, and the directrix. When I look at this first problem, one of the first things I notice is that the y is squared. So I'm going to remind you of the standard form for a parabola when the y value is squared. Remember that this parabola is either going to be opening left or right, not up or down like we were used to. As I look at this standard form, I want to get my y's to be a quantity squared, and then notice my x terms have moved over to the other side. So I'm going to start by doing that to this equation. So I'm going to leave y squared and 2y on the left, and I'm going to go ahead and set that equal to, I'm going to add 6x over and subtract 13 over. Now here's where completing the square is going to come into play. As long as this y squared has a coefficient of 1, we can change it into this quantity squared by completing the square on the left side. Remember, the key step to doing that is to take your b value, divide it by 2, so half of b, and then quantity square that. Half of my b is 1, and when I quantity square that, I get 1. So I'm going to add that 1, not just to the left side, but also to the right side. What happens now is this left side is a factored form. It's a perfect square here, so we have a y, and if you look at this, we definitely need a plus 1 quantity squared, and this would create y squared plus 2y plus 1. On the right, we have a 6x minus 12. Now, the right is where we still need to do some work to get into the standard form, because we always want that 4p quantity to be outside of our parentheses and then just an x minus h left over. So I need this to just have a 1x, so that means I need to take this entire 6 out. Luckily, this works out nicely, and 6 comes out of 12 evenly, so I don't have to worry about fractions here. And this would be my standard form for a parabola. Now, I've also asked you to give me the vertex, the focus, and the directrix, so we need to investigate this equation just a little bit more. Remember, it was a y squared, so I told you at the beginning this is definitely going to be either facing left or right. Because we are positive over here, we are going to be facing the right with a vertex at the ordered pair h, k, so 2, negative 1. Now, in order for me to figure out where my focus and directrix are, I'm just going to give myself a quick little sketch of what's happening here. Alright, again, not perfect, but I at least have an idea, and I realize, okay, my focus needs to be inside, and my directrix needs to be behind. And I also notice my directrix is going to be a vertical line. So some of these little pieces of information are definitely going to help me as I calculate these other two pieces. In order to know my focus, I need to know what p equals, because the focus is p units away from my vertex point. Remembering from your equation that this 6 represents 4p, which means p must equal 6/4, or, as many of you are thinking, 3/2. So now as I create my ordered pair for the focus point, it's the x value that's going to move So I need to go to 2 and then add that p-value of 3 halves. The y value remains the same, so I know it's going to be a negative 1 y value. And then 2 plus 3 halves, if you get a common denominator of 2, we now have 4 halves plus 3 halves. That gives us a 7 halves, negative 1. So this is my focus point. My directrix line is actually going to be behind my parabola, and to get that value, I need to look at my x value of the vertex, and instead of adding p, I need to subtract p. So my directrix line, because it's vertical, is an x equals equation, and I need to take that x value of the vertex 2 and subtract 3 halves, and when I do that, I get x equals 1 half. So now not only have I gotten this equation at the beginning that didn't tell me a whole lot into the standard form for a parabola, and I've been able to find out a lot of information about this particular parabola. Let's go ahead and look at this second equation. Notice what I've changed for you in the second equation is, instead of the y being squared, the x is squared. So this is going to either be a facing up or down parabola. A reminder of what the standard form for an x squared parabola looks like. So this time we need to get the x's by themselves, and we'll move the y's to the other side of the equation. Add the 4y and add the 9. Now, I cannot complete the square yet. Hopefully you remember this rule. This coefficient with the x squared needs to be 1. So I'm going to go ahead and divide both sides of my equation by 3 so that I can get this to be a 1. Unfortunately, this might create some fractions for you down the road. And then over here, not too bad. We just have the 4/3 y, and then we have a plus 3. We are ready to complete the square at this point. Half of b, again, is 1, and squared is also a 1. So I'm just adding 1 to both sides. This is now what we call a perfect square trinomial. It will factor into the same two quantities, in this case x minus 1, remember the sign is very important, equals, we have a 4/3 y plus 4. We still have this issue that we had on this side where we need, in parentheses, this to just be a y plus some quantity. So that means I need to get this 4/3 out of the picture, so I'm going to factor out a 4/3. Now here's your problem. It factored out of the first term easily. However, factoring a 4/3 out of a 4 for some of you might be a little tricky. All you're really doing, folks, is dividing 4 by 4/3. And since we don't like dividing by fractions, we're really multiplying by the reciprocal. This actually is not so bad, as this really just needs to be a 3. So if you need to think about that fraction work for a second, please do so. But this is not too bad of a fraction to deal with at this point, and our left side stays the same. So here is our new standard form. Now the information we can draw from this is, number 1, the vertex is going to be hk 1, negative 3. And because this is x squared, remember I said it was facing up or down, because over here is positive, it is going to be facing up. And I'm going to go ahead and just give myself a little sketch off to the side. So we're at 1, negative 3, and we are facing up. Again, just a sketch. I need to get my focus point and my directrix line. In order to know those values, I need to know p. Remember that this quantity represents 4p. Again, some more fraction work for you. So 4p equals 4/3. So if I divide by 4, I like to think of that as really multiplying by 1/4. And this ends up letting p equal 1/3. So again, Not too bad with the fractions. Let's finish this off. I need my focus point. This time, it's the y value that is going to be affected, so my x value of 1 stays constant, and instead of going all the way down to negative 3, I need to only go down a little bit less than that, so I need to figure out what that value is between negative 3 and the 1/3. So if I add 1/3 to that negative 3, get a common denominator here, I end up with a negative 8/3. So negative 2 and 2/3 is how far down you go for that focus point. My directrix line is actually going to be below that. So this directrix line is a y equals equation, since it will be horizontal. And we're not going to negative 3. We actually need to go 1/3 farther than that. So here's where you have to watch. I need to subtract 1/3 from the negative 3 to make it go below the negative. And when I simplify this out, I get a negative 10/3. So folks, really a visual helps you understand if you should be adding or subtracting the p-value, so I do strongly recommend giving yourself that little visual as you answer some of these questions. Hopefully that helps, and you've got some problems on your problem set to work through, and good luck.